Hi everyone. Here we are going to see about the Unit 5 continuation class for the today's class. So let me see what are the topics we are going to see about the Unit 5. So typical Mac execution cycle. So that is we have to obtain the sample of the input signals. So it should be moves the input sample into input buffer. Next it can fetch the coefficients from internal buffer. So we have to multiply the input sample by coefficients. So add the product to the accumulator level. So this accumulator will move the output to the output buffer. So then after moving the output buffer, it will be passed send into the sample of the output signals. Here is the Mac execution hardware. So that is so we have the program coefficient memory. So we have to use two methods. One is the program or coefficient memory and another one is data memory. So first we have to pass the program counter. So this thing will be made into the counting the programming, and then the data read address as well as the data write address. So the addresses will be mentioned. So we have to read as well as write both the values. After that, the values will be sent into the processing method. This processing will be stored in the memory, that is the program or coefficient memory or data memory. After that, it will be sent into the accumulator. The accumulator will store the data values and then pass into the CPU processing unit. So architectures of the digital signal processors is that the general purpose processors are based on the von Neumann architectures. So it means that single memory bank and processor access this memory bank through single set of address and data lines. Here we are having the Harvard architectures that is commonly used in the digital signal processor. So separated data and program memories are having that should be based in the two memory banks. So this architecture should be used for this digital signal processing systems. Next is the separate address buses for data and program memories are be used for architecture of digital signal processor. Next is the additional features in a DSP processor. So the instruction cache and pipeline processor are in any modern microprocessor. So that should not be having the no data cache. So separate ALU should be used, multiplayer and shifter. So it should be connected through multiple internal data buses, and it should be enable the fast MAC operations. So this MAC operations will be used for as an additional features in the DSP processor method. Next, DSP, CISC and RISC. So DSP processors that can be called truly as a CISC or RISC type of processor. So some features of present in the RISC processors that may be exist. However, DSP processors are turned towards the operations, and it should be operated in the encountered in signal processing applications. So RISC processor is that reduced instruction set computers. It should having the variety of RISC processor that should be designed to include the ARC processor. So the DEC alpha, that is the AMD AM29000, the ARM architecture, the Atmel AVR, Blackfin, Intel i86, etc. CISC processor means that is CISC means complex instruction set computers. So it should be having the processor that have a larger set of instructions with many addressing modes. So this maintain the most of the methods. So RISC CPUs are generally run faster clock speeds than CISC because maximum clock period is dictated by the slowest step of the pipelines. So more complex instructions are slower than that of the RISC and CISC processors. Next is the Dsp implementation approaches. So the Dsp implementation approaches are it should be having the important desirable characteristics. That is adequate word length, can fast multiply and accumulate the method. So it should having the high speed RAM and it has a fast coefficient table addressing. So fast new sample fetch mechanism into the digital signal processing of time. Next, DSP functions that should be implemented with IC chips. So here you are having some of the issues, that is speed features. Next thing will be the architectural accuracy, length and floating point capability, registers, cost in VLSI. Next thing will be the advances, then techniques. So these are the functions that should be implemented in the integrated circuits of chips. Next is the general purpose DSP features. So first thing will be the parallelism, that is the multiple function units. It should having the multiple bases, multiple memories. Second thing will be the pipelining. Third thing will be the hardware multipliers and other arithmetical functions. Next thing will be the hardware multipliers and other arithmetic functions on chip of and cache memories. Variety of addressing modes are occurred in the general purpose DSP. Then instructions that should be having the pack several operations. Zero overhead looping. Next is the input or output features such as interrupt, serial input or output, and also the DMA. So the last thing will be the other control functions such as wait, states, etc. So it should be also used in the purposes of DSP features.